Sine, this is k goes from 0 to n minus 1, cos to the power k theta, sine to the power n theta, pi to the power n sine theta. So how do we apply this thing? I will give other application also, means how do we do that? There are two different ways to do. So let's first convert it into cos. So pi by 22, how do we write it in terms of cos? I need 11 on the top because the sum of the two numbers, the sum of two angles is pi by 2, then only we can be cos, because cos pi by 2 minus theta is sine theta. So pi by 22, what I add to get is pi by 2. So I need here 10 pi by 2, correct? So I can write it here cos of 10 pi by 22. Are you understanding? Hello. Hello.
Yes.
What are you understanding? Sine
So
theta
we can.
is cos of pi by 2 minus theta. So instead of writing it, I'm just converting directly. If I have sine 60 degree, can you not write cos 30 degree? Because I know that the sum of the two angles is 90. So similarly, there is a sine 22. I can directly see that what the cos corresponding term is there. So I have pi by 22. I need 11 pi by 22. Then only it will become pi by 2. So I'm adding 10
Yes.
pi by 2. So we get here cos of 10 pi by 22. What do we get this thing? Cos of
8 pi by
8 pi by 22. What about this?
oh,
6 pi by 22. Then cos of 4 pi by 22. And then finally cos of 2 pi by 22. Is it clear?
yes, sir.
Okay. Now see one thing here. This is what 2 cos of this I can write 5 pi by 11. This is cos 4 pi by 11. This is cos 3 pi by 11. Cos 2 pi by 11. And cos pi by 11. After this, we can do one thing. I'm taking cos pi by 11, cos 4 pi by 11, and cos 2 pi by 11, and cos 4 pi by 11 together. And the remaining left out terms are cos 3 pi by 11 and cos 5 pi by 11. Correct? Yes or no?
Yes, sir.
Good. Then mute the mic after speaking, then you can mute it. Okay. Now see, it will become cos theta, cos 2 theta, cos 4 theta. Cos theta, cos 2 theta, cos 4 theta. And there from the formula, you can see that this is cos theta at the first place, because when k is 0, that will be theta. And the place of theta, there is a pi by 11. Then cos 2 theta, that means cos 2 pi by 11, and cos 4 theta, that is cos for the k is equal to 3. So basically we are going up to 3 terms. So only you have to count out how many terms I have. And so the n value is 3. So for this thing, I can write that. But before that thing, can we make this thing better? So I'm just keeping that hope alive. And I'm thinking that whether that can be written as the next 2 terms of the same series or not. So notice one thing. In trigonometry, you know this thing, the cos of pi minus theta is minus cos theta. So this cos 3 pi by 11, I can write as minus of cos pi minus pi 3 pi by 11. Because cos of pi minus 3 pi by 11 is minus of cos 3 pi by 11. There's a minus sign there. So I can write it safely. And here there's also one formula, cos of pi plus theta is minus cos theta. So with this help, I can use this one and write it as minus of cos pi plus pi by 11. It means there's a minus of cos pi plus theta is minus cos theta, this minus will get cancelled. So now these two minus will make it plus, and let's write that angle in the simplest form by adding that. So that will become cos 2 pi by 11, then cos 4 pi by 11. And you notice this will become 11 pi minus 3, that is cos 8 pi by 11. And also this is cos 11 pi plus pi by 6, so cos 16 pi by 11. And now this will fill all those details, because theta is now theta is pi by 11, and every term is now in this series of this cos to the power k theta in the product. So you can notice that this is how many terms I have. 1, 2, 3, 4, 5. It means the n value is 5. So I can write sine to the power 5 and theta, which is pi by 11, divided by 2 to the power n, that is 2 to the power 5, and sine theta is sine pi by 11. So from there, this 2 and 2 to the power 5 will make it 2 to the power 4. Sine to the power 5 is 32 pi by 11. So sine 32 pi by 11 is here. And in denominator, I have sine pi by 11. But here, the sine 32 pi by 11, I can write it as sine of 3 pi minus pi by 11. 33 minus pi. So this will give you sine 3 pi minus pi by 11. That is nothing but sine pi by 11. So I'm left with sine pi by 11, sine pi by 11 cancel, and you are getting with 1 by 16. So that is the answer.
Okay,
Yes,
sir. Yes, sir.
Okay. But let me give you another way to think. What is another way to think it? Let's see. So please keep in mind, this is a very long, yesterday I taught one student online only that process. How do we prove that thing? But I'm not going to give you the proof because it's very lengthy. So the idea that please keep in mind. Oh, keep it where you do. Suppose you have the product of, when I'm writing pi, it means the product. A goes from 1 to n minus 1. And then the sign has this thing, a pi by n. So what is the first term you get here? Pi by n, then 2 pi by n, then 3 pi by n, and so on. So that product will give you the n by 2 to the power n minus 1. So let me show you a little bit the proof that nature, because very this is the formula, we have derived it, and you see this is all the things we have done with the complex number. So this question I have taken again yesterday, and I had this formula 2 to the power n minus 1, n by 2 to the power n minus 1, and then we are proving it by using the complex number. So first of all, we take this binomial equation, then after that all the complex number, and then after long calculation we prove that this formula exists. But I don't want you to learn this formula, because the proof actually, because it's very lengthy, and when a complex number comes, then we will also learn it. So this thing, how it will help to make our solution shorter for this question. So let's try to think. So here the question is, and you have to be very careful when and all such type of questions, guaranteed you can do it very quickly if you are looking this thing very carefully. So see it here. This is k pi by n, and the meaning of this thing is, suppose I want to write the fullest one, like k goes from 1 to n minus 1. So how do we realize that what is happening? So the meaning is that, suppose I want to write n is equal to, let's say, 10. So how do we understand this? This will be open up. So I will write sine pi by 10, then sine 2 pi by 10. I'm taking example. Then sine 3 pi by 10. Then sine 4 pi by 10. And all the way up to sine 9 pi by 10. You notice one thing, because the k goes start from 1 but goes up to only n minus 1. So if the n value is 10, the denominator of this pi is 10 there, we have to take this series up to 9 on the denominator, so numerator. So it will give 9 pi by 10. So basically it's coming from the complex roots of unity, but we are not going into it. And so the answer of this thing directly you can write as 10 by 2 to the power 9. Okay, so this is the best way you can apply, and we don't have to calculate this much. And I will show you how many questions are related to that. So let's try to understand whether this thing I can apply here or not. So if you notice this thing, there's something missing. The missing is that if I have the denominator of pi is 22, the series should end up to 21, because the denominator is 22, so numerator must end up to 21. Moreover, I have sine pi by 22. There is no sine 2 pi by 22. Then also sine 4 pi by 22, and also sine 6 pi by 22, and 8 pi by 22. It means we are missing all the even terms. So sine pi by 22. So first one is sine pi by 22, then sine 2 pi by 22. Once you understand this question, even if you don't solve it in first or two steps only, the students can get the answer. I'm actually saying it from my experience. Even today also, the 5 or 6 questions which are previously asked, they have done by like that in one go. But first of all, you have to understand everything. 3 pi by 10, then sine 4 pi by 10, and up to, I have to write up to sine 21 pi by 10. So I'm writing 20 pi by 10. Sorry, 20 pi by 22, no, sorry, all 22. And then sine 21 pi by 22. It means that must be the answer as 22 by 2 the power 21. Is it clear?
Yes, sir.
Okay. All right. Then what we do, because I need only the odd parts, but notice one thing, it's a very interesting fact. Sine pi by 22 and sine 21 pi by 22 are the same, because this is pi minus pi by 22. So again, sine 19 pi by 22 and sine 3 pi by 22 will become same. Means all the pairs of odd I'm taking with odds, and all the evens one I'm just taking aside. So what I'm going to do, I'm writing here sine pi by 22 and sine 21 pi by 22. This both are same, so I'm writing is as the square, means both are same. Now sine 3 pi by 22 and sine 19 pi by 22 also same, so I'm writing for both of thing, I'm writing sine 3 pi by 22 once. Then sine 5 pi by 22 will match to 17 pi by 2. So they'll give you sine 5 pi by 22. Then for 7, we have, for 7 what we have, 15. And then for 9, I have 13, correct? 9 pi by 22. I have 13. So 13 and 9 are same. So I can, now you say 11. But 11 and 11 are not twice because they are same. So we don't have a match of 11. But the good thing is that sine 11 pi by 22 is nothing but sine pi by 2. So sine 11 pi by 22, I'm writing once because there is no pair. And the remaining terms are even terms. Even means the coefficient of pi by 22 is even numbers. So what are those? Sine 2 pi by 22, then sine 4 pi by 22, and up to sine 20 pi by 22. And that is equal to 22 by 2 to the power 21. Is there any problem so far, Yosha?
No, sir.
Very good. It means now you can write this thing as P and the square, correct or not?
Yes, sir.
P square, okay. And this guy is sine 11 pi by 22 is sine pi by 2, that is 1. So this is 1. Now what about this? Now cancel each 2 in the numerator for each of the terms. So you'll get sine pi by 11. Then I get sine 2 pi by 11. Then sine 3 pi by 11. And all the way up to sine 10 pi by 11. And this is 22 by 2 to the power 21. I can write it as 11 by 2 to the power 20. Now, can you just be very, very, very careful and tell me, observe this thing and tell me what is this thing? There is a new piece of the same structured formula. Because this is pi by 11 starting from 1 and ending up to 10 and the denominator is 11. Yes or no?
Yes, sir.
So what I can write for here? Tell me.
11 by 2 to the power 10.
You see? And that is going to be 11 by 2 to the power 20. So I have to find P value. So P square, what I'm getting is 11 cancel. So 2 to the power 10, this is 1 by 2 to the power 10. And so P value is 1 by 2 to the power 5, that is 1 by 32. And this was the P value, remember, I have to multiply with 2. Therefore, the answer is 1 by 16. You got it?
Yes, sir.
Now, the good thing is that even this is actually very practical things not given in any book. And today only 5 or 6 questions all the students did orally. I don't know how they will apply this thing if it's coming exam or not. But in front of me, they have done this thing. How orally they can do it? You can notice that if each of the questions of like that is a similar pattern, because every piece will be square always. With the odd terms are they asking, we have to make the square, that's it. And the even terms will construct a new series, and you know what to do after it. Understood?
Yes.
So this is the thing. Now you notice this question, by the way, this is they have asked you, like, okay, so this thing is alpha minus 1 by 16 sine 10 degrees. There is another way to do it also, but let's for the test whether this is applied or not. 16 plus alpha to the power minus 1, I have to find it out. So this is given like that. The only barrier is this part, that this part I can write in this form or not, miss by simplifying or not. That's a different thing, but we can do it. So let's try. So there's sine square 10. So 1 sine 10, I can just remove it. And sine 10, because we have learned this theory with the help in terms of pi only. So I can just write everything in terms of pi, and at the end I can change in terms of degree. Means correct. So I can write it as sine pi by 18, because 10 degrees pi by 18, 180 by 18. So one piece I'm taking alone, and then I'm writing sine pi by 18, then sine 2 pi by 18, then sine 4 pi by 18, 3 is not given, then sine 5 pi by 18, then sine 7 pi by 18, again this thing not given, 6 is not given. But you know that to get the fullest answer, this value, I have a p value, I'm saying it. I'm not calling this thing, I will attach after. So let's write the fullest one. And the fullest one, you know how to write? Sine pi by 18. Even you don't write, you know that. Then sine 2 pi by 18. And fullest one, in fullest one, I have 3 pi by 18 also. Correct or not?
Yes.
Then sine 4 pi by 18. Then sine 5 pi by 18. What is missing after this? Sine 6 pi by 18.
Yes, sir.
Then sine 7 pi by 18, and up to what? Tell me, up to where I have to go to write the fullest? Sine
17 pi by 18.
Perfect, very good. Sine 17 pi by 18. And that is going to be what? 18 by 2 the power
2
17.
power 17.
Very good. Now, can you tell me what are the two pieces are together and what? 17 and 1, 2 and 16, 3 and 15, 4 and 14. All are giving the same value. So up to where I have to make a double? Can you tell me? Up to 8 pi by 18. Correct or not?
Yes.
Because 9 pi by 18 will become pi by 2. So wherever the pi by 2 will become, after that all the values will be replica of the previous values in every such series. Correct or not? Because 9 pi by 18 has no such other co-partner to make it square, because this value is 1 also. So I'm writing this thing as sine of pi by 18, 2 pi by 18, up to sine 8 pi by 18, and the square of it, that is equal to 18 by 2 to the power 17, which is nothing but 9 by 2 to the power 16. Correct? Now this value, I will get what? Sine pi by 18 up to sine 8 pi by 18 is equal to 3 by 2 to the power 8. Correct or not?
Yes, sir.
Okay. Now see, in this whole series, what are the 3 extra things we have written? Sine 3 pi by 18 is there. Then sine 6 pi by 18 is there. And sine 8 pi by 18 is there. Correct?
Yes, sir.
It means I can write P is nothing but 3 by 2 to the power 8. And I'm dividing by all those 3 values. That is sine 3 pi by 18 sine 6 pi by 18 and then sine 8 pi by 18. Agreed?
Yes, sir.
Very good. But the good thing is also that I have 3 pi by 18 as pi by 6. Sine pi by 6 is 1 by 2. 6 pi by 18 is root 3 by 2 because sine 60. And sine 8 pi by 18 is nothing but cos of pi by 18. Why? Because 8 pi by 18 plus pi by 18 is pi by 2. Therefore, sine of 8 pi by 18 is nothing but cos of pi by 18. Correct? So let's simplify this. So I'll give you 3 by, and this is going to be 2 cancel, so 2 to the power 6. And this is root 3 now because root 3 will also cancel, and this is giving you 1 by cos of, and pi by 18 I can write with the 10. But I have to find out this thing. You notice this, I have sine 10 degree in the front attached. I have taken only this part as P. So I'm writing now sine 10 into this part. So sine 10 degree into P is nothing but root 3 by 64 sine 10 degree by cos 10 degrees. Correct or not?
Yes.
This is tan 10 degrees you can write. But the problem is, I told you, this part is the problem. I need this thing in the form of alpha minus 1 by 16 sine to the power 10. So suppose you are preparing for advance. Suppose, actually not suppose, you are already preparing for advance, I'm wishing. So the thing is that maybe they, suppose this kind of question they can ask in the multiple correct, that this is also correct choice. And after substituting the correct value of alpha, they create a new options for you. But the challenge for us here in front of us is that how do we convert this thing into the difference of this thing, which alpha minus 1 by 16 sine to the power 10. You get it? You are getting my point?
Yes.
Yes. So let's convert it. Now you see in this whole thing, the minus and this thing, I don't have any root there. And also the terms are in terms of sine 10 degree. There's no cos 10 or anything. Alpha is a constant. So first of all, I will try to kill this or utilize this root thing. How do we utilize it? What I'm taking, I'm borrowing this 1, 2 from here, and I'm writing this thing as 1 by 32. And please be very careful. Root 3 by 2, sine 10. And divided by cos 10 degrees. Correct? I don't have any cos in the denominator. So for that, I'm writing this root 3 by 2 as cos 30 degrees. Can I write it like this? Is it clear?
Yes, sir.
Yes. Because I don't need this cos 10. How do we cancel this cos 10? So to cancel, here I'm applying the cos 3 theta formula. See, very unusual way you are learning this trigonometry. Please understand. 4 cos cube 10 minus 3 cos 10. Correct? Can you write like this?
Yes.
So as soon as you write, do you see that the cos 10 will get cancelled?
Yes, sir.
Taking the common. So what do you get here? 4 cos square 10 degree minus 3, and then you are multiplying with sine 10 degrees. But I need everything in terms of sine. So again, I'm converting this cosine square 10 as in the form of sine. So this will give you 4 minus 4 sine square 10 degrees minus 3, and then sine 10 degrees. And then we get here 1 by 32. And that is nothing but sine 10 degrees minus 4 sine cube 10 degrees. But again, the problem is I don't have sine cube 10 in the expression what is given in the right hand side. So I have to convert this thing again in terms of sine 10. So how do we convert? We know that sine 30 degree, I can write by using the sine 3 theta formula as 3 sine 10 degrees minus 4 sine cube 10. So this minus 4 sine cube 10 directly I can replace as sine 30 minus 3 sine 10. Sine 30 is half, so half minus 3 sine 10 degrees. And now it's all done. So you get here 1 by 32, 1 by 2 minus 2 sine 10 degrees. Multiply this 1 by 32 each of the term. So you get 1 by 64 minus 1 by 16 sine 10 degrees. We got exact expression what we are looking for. Alpha minus 1 by 16 sine 10. Understood?
Yes, sir.
You see how it's actually, see, the trigonometry adjusts itself. The only thing we have to see or understand the manipulation where is going on. So even you get the answer from every student I just solved them, they got this answer. He said, this is a challenge for you to get the answer in this form. Now I'm going to teach you the same question in a different way. It's shorter, but this is also very profound. I just exhibited that how can we utilize this formula anywhere. If nothing is coming to your mind, this formula is a kind of a master key. You can apply in such kind of scenario. It will always work. You get my point?
Yes, sir.
Okay. Now let's do this question in a different way. Okay. I remember actually I gave you this formula if you remember, I think. No, if not, then just write it. Sine theta, sine 60 degree minus theta, and sine 60 plus theta. Do you know what this formula is? It's 1 by 4 sine 3 theta. And for cos also the same thing. Means cos theta, cos 60 degree minus theta, and cos 60 degree plus theta is again 1 by 4 cos 3 theta. Okay. And the third formula I want you to remember that sine A plus B into sine A minus B is sine square A minus sine square B. Why I'm stressing this thing? The stress is on remembering because in trigonometry, there are some formulas whose derivation are very lengthy. So of course, in examination, you will not sit to derive all the formulas. And if you apply this thing or it in memory, you can make it shorter. So see here, what I'm going to write it, this one, as there is 2 sine 10 degrees, means 2 pieces of that. So I'm just giving like this, sine 10 degrees, sine 20 degrees, and sine 40 degrees together. And then sine 10 degrees, sine 50 degrees, and sine 70 degrees together. You notice one thing here. This is sine 10, that is theta. This is 60 minus theta, because 60 minus 10. And this is nothing but 60 plus theta. Correct or not?
Yes, sir.
So can we write directly 1 by 4 of sine 3 theta? 3 theta is 30. So that will directly give you sine 10. And this I can write as sine 30 minus 10. Because we are looking for the symmetry to use our formulas what I know. This is 30 plus 10. And this is already 1 by 4 into sine 30 degrees. Now here I can apply Sine A minus B, sine A plus B. So this will give you sine square 30 degree minus sine square 10 degrees. This is sine square A minus sine square B, correct? And this one will give you 1 by 8. This is 1 by 4. So we're getting 1 by 4 sine 10 degrees minus sine cube 10 degrees. And you can notice we are actually in the same situation where we got the second, this situation here. Are you getting this thing?
Yes, sir.
Yes, because if we take this 1 by 4 out, I will get 1 by 32 in the front, and they'll get sine 10 minus 4 sine cube 10. And after that, I have already calculated. See, from there, I have 2 more steps and we get the same answer. Understood? So this is actually quite shorter, but both of the methods are wonderful, like good one. Got it? This is actually we are learning this kind of application first time, so that's why maybe we are struggling to figure it out what is happening. But after 2 or 3 questions, you realize that is also the first 2 steps or 3 steps we don't have to do. We can calculate in mind itself. Okay, and from there we can do the remaining steps. Understood?
Yes, sir.
Okay, good. So next, what we should do. So this thing, wait, sine of the summation k goes from let's say 0 to n minus 1, and sine of theta plus kd. Have I solved? We actually discussed it. No. So what is the formula? Sine of theta plus n minus 1 d by 2 sine of n d by 2 divided by sine d by 2. Okay. And if there is a cos also, we can make it the replica of it. Cos of theta plus kd, and that is cos of theta plus n minus 1 d by 2, and that is sine. Here there is no change, term will change, and denominator also will not. Okay. So what is the meaning of this? These angles are in 80 because the first term